Assalamualaikum and greetings to Dr. Zaitun, our lecturer, and all of my friends and audience. Today I welcome you to hear about our group presentation on our assignment. The assignment title are based on optical wireless communication in amplitude modulations. Before we start, I would like to introduce my teammates, which is Muhammad Ikhwan Shafiq bin Anwar, myself, Muhammad Fali bin Muhammad Noor, and Muhammad Nasri bin Wan Abu Bakar, then Mas Nizan binti Anwar, and the last one, Muhammad Syaril Izwan bin Muhammad. First of all, I would like to go on to the objective of this assignment, which is the assignment objective is to familiarize the optic system simulation software on optical wireless communication. So basically, the assignment gave us better understanding on optical simulation system called OptiWave. With the introduction of this system, our knowledge on how optical wireless communication has been enhanced. But more importantly, our most important objective is to observe performance characterization of amplitude modulation system using optical modulator and electrical modulator. This characterization are observed in terms of BER analysis, I diagram, and Q factor. The results will be shown next on the results section.
Hello, I'm Muhammad Nasri. I will present about simulation design and method. For the free space optical communication system, the circuit is for without AM modulator. For this system, it consists of three systems, which is optical transmitter, channel, and optical receiver. In the optical transmitter, we have four subsystems, which is first pseudo-random sequence generator. It is represent information or data that wants to be a transmit and output. It's a bit stream, binary pulse, a sequence of 1 on or 0 off. Then next one is return to 0 electrical alternator. It creates a sequence of return to 0 pulse followed by an input digital signal. Then we have CW laser, which is continuous wave laser. It's a laser that emits a continuous laser beam with a controlled output as beam duration and intensity. Then, the last process of optical transmitter is Mach-Zehnder modulator, which is an optical modulator that the function is to vary intensity of light source from the laser according to the output of the return zero pulse generator. For the next subsystem is channel. The channel have one FSO channel, which is free space optic channel. It is function to propagation medium for the transmit light. Then for the last subsystem, we have optical receiver. It consists of three parts, which is pin photodiode, which is function to absorb in the intrinsic region and carry generated therein can efficiently contribute to the photocurrent. Then you go to low pass Bessel filter, which is this type of analog linear filter with a maximally flat group of phase delay, which present the wave shape of filter signals in the pass band. Then, for the last process, this 3R generator function is used to generate electrical signal of the original bit sequence and the modulated electrical as in the optical transmitter to be used for bird analysis. The analysis is done by using the bird analyzer, which to analyze the bird analysis, Q factor, and bird pattern. Okay, next, for the fixed space of the system, communication system, the circuit has AM modulator, which is placed in the optical transmitter. It is put after return to zero pulse generator. This electrical amplitude modulator can produce a high frequency signal that is multiplied by a low frequency signal. For for each part of the subsystem, the requirement will fill into each of the component to produce the signal, and the signal produced will be shown in the bird analyzer to see the bird analysis vector and bird pattern. Thank you.
Hi, we meet again. So I will be explaining on result that we get from the simulation software OptiWave. So in this section, the result of circuit simulation are discussed. The circuit are tested with and without an external modulator. For this part, this circuit are using an external modulator, which is an amplitude modulator. So clearly, there are huge difference can be seen when testing the circuit in these two conditions. Comparing with these two conditions, the result from BER analyzer shows that the output form of the circuit resembles as amplitude modulation in basic communication system. Both conditions are tested with specific attenuation range. So the attenuation range are set to 5, 25, and 65 dB per kilometer. The software itself will generate and result at here. So all the data are taken from this side. So we can collect the data and tabulate the data. So the data taken will be characterized by three form, which is Q factor, BR analysis, I diagram, and that's all. All these three will be recorded. Then, as we can see in this result, this result are using circuit without an external modulator. So there's no modulation, external modulation can be seen. So even so, we take the data to make comparison which system give more benefits. So the same, we take the data in this diagram or table. Next, the data are tabulated. As we can see, the attenuation are set as we speak before, 5, 25, and 65 dB per kilometer, with and without external modulation. So then we proceed to the graph result. This is the maximum Q factor versus attenuation graph. And then we move to maximum Q factor versus attenuation without external modulation. Previously was with external modulation.
Assalamualaikum to Dr. Zaitun. I will continue the presentation with the experiment analysis. As you can see from the table 1 is the result of all the parameters we gain from these simulations that include with external modulation and without external modulations. From the table, students observe that maximum Q factor decrease when the attenuation is increased, and the higher the Q factor value, the lower the BER. In telecommunication transmission, the bit error rate is the percentage of bits that have error relative to the total number of bits received in a transmission. Next, the result which external modulation shows the I height has lower value which is in negative, while without external modulation the I height had higher in positive value. This can happen when the signal had too many noise. As you know, eye height is a measure of the vertical opening of an eye diagram. An ideal eye opening will be measured from the 1 level to the 0 level. However, noise on the eye will cause the eye to close, which means The eye height measurement determines eye closure due to noise that can be seen from the eye diagram in the result. From the result, we made a graph maximum Q factor versus attenuation with external modulator and without external modulator. From the graph of both figure 5.1 and 5.2, it can be observed that maximum Q factor increase when attenuation is increased. Unfortunately, from the graph 5.1, students see the slightly different proportional that may be occur because of simulation error, since the max Q factor is supposedly directly proportional to attenuation value. The higher the attenuation value, the higher the max Q factor, while vice versa to the BER. For more discussion, I will pass the presentation to my friends, and thank you.
Hi, Assalamualaikum. My name is Muhammad Syahrizwan bin Muhammad. I will uh, I will present about the discussion for this assignment. Okay. Basically, from the result that has been observed in this experiment, in attenuation with external modulation, show low output of maximum quality factor, with highest value only at 1.69. This can this can translate as the pulse in the result is highly prone to the noise. Different from the attenuation with external modulation, the maximum quality factor for the attenuation without the external modulation shows a high maximum quality factor at value of 6039.53, which indicate the pulse is relatively free from noise. Next, the bit error rate for the attenuation with external modulation is 0.05 at the highest attenuation, meaning that out of the 50,000 bits transmitted, 1 bit was in error. As for the bit error rate for the attenuation without the external modulation is 0. This can be translated as no bit error during the transmission. Moving on to the eye height attenuation with external modulation. The eye height attenuation is only at 0.415, which means the height is relatively short, thus indicate the result is prone to the noise. On another result, the eye height attenuation without external modulation is 0.909, which is longer height than the height attenuation with external modulation. Thus, the result is slightly resistant to the noise compared to the eye height attenuation with external modulation. Okay, from the two comparison between the attenuation with external modulation and the attenuation without external modulation, the result shows the attenuation with external modulation is more affected to the noise during the transmission compared to the attenuation without external modulation, due to the external modulation using higher wavelength making the transmission more prone to noise. Okay, thank you.
Assalamualaikum and very good morning to Dr. Zaitun, Binti Abdul Muttalib and all my friends. There are two objectives that are complete, which are to familiarize with optic system simulation software on optical wireless communication. Secondly, analyze along with assess the performance characterization for your system based on specific modulation format using optical modulator and electrical modulator in terms of BER analysis, eye diagram, and Q factor. Lastly, they has emerged as a viable technology for next generation broadband wireless applications in different areas of the long and short haul communication space, from link of inter-satellite to link of inter-building. Next, they has emerged as a viable technology for next generation broadband wireless application in different areas of the long and short haul communication space, from link of inter-satellite to link of inter-building. There are two comparisons that can be made in regards satellite selecting the data which is with and without an external modulator. There are more contrasts that occur when the free space optical is in high level position. As you can see, the graph shown in the result field clearly shows that every part of modulator influence the characteristic at output waveform depend on their own capability.